Hello everybody, I'd like to talk about the factoring of difference of two squares. First of all, the formula we are using in order to factorize the difference between two squares. If we have two terms, the first one is squared and the second one also squared, and the sign between them is the subtraction sign. Simply we can simplify these squares into two factors. The first factor is the sum of the first term plus the second term. This is multiplied by the second factor, which is the first term minus the second term. So this is called a difference of two squares. So we have a binomial, we have two terms. These two terms are squared, which means that they have an exponent of 2, and because the sign in between is the subtraction. First of all, let's prove geometrically the formula of the difference of square, which is x squared minus square. Imagine that we have a square which with dimension x times x, same like what we have here, and we have a small square inside with dimension y and y. So we need to subtract the area of the small square from the area of the biggest square. So we need to compute for x squared minus y squared. So what we need here is to compute for the area of this, excluding the small area of the squared y. So this is considered to be x squared minus y squared. So if we try to extend a dot line, same like what we have here. So this is y, and the total of this length is x. So the dimension here is x minus y. Again, regarding the dimension of this length, which is x minus y, the total length of this square is x. So we subtract this dimension, which is the dimension of the small square, which is y. So we have x minus y. If we try to move this colored rectangle here to be side with the rest, we get this new shape. So by this we have a rectangle with two dimensions. The longest dimension is simply original x plus y. Y comes from the moving of this part here. And regarding the second dimension, it is simply x minus y. So this proves that the value of x squared minus y squared is simply a rectangle of two dimensions. The first is x plus y, and the second is x minus y. This is the formula for the difference of two squares. Let's recall. We have two terms. The first one is squared, and the second term also squared, and we have a minus sign between them. This can be factorized to two factors. Simply the first one is the first term plus the second term, and this factor is multiplied by another one, which is the first term minus the second term. Let's do these examples together. First, factor the binomial x square minus 25. So the first term is x squared. It is complete square term. So what about the 25? 25 is simply can be considered to be 5 to the exponent 2. So x squared minus 25 is simply equal to x squared minus 5 exponent 2. So in this case, we have two terms which are perfect squares. So we can apply the formula for the two terms or two squared terms. So we have two factors. First, we put x at the starting of each two factors. Then we have two signs. The first is plus and the other is minus. And we put the second term, which is the 5. So these are the factors for the binomial x squared minus 25. Let's do this example together. We have a binomial which is 9x squared minus 81. So before starting solving this binomial, we need to make two perfect squared terms. So regarding for the first term, which is 9x squared, simply we can consider it to be 3x all squared. So the first term becomes a perfect square term. And regarding the second term, which is 81, we can consider it to be 9 squared. So again, the second term is also a perfect square terms. Now we can do the factorizing. So the original binomial, which is 9x squared minus 81, is simply 3x all squared minus 9 all squared. So we have this is the first term, which is 3x, and this is the second term, which is 9, and we have a minus sign between them. So by applying the formula, the first factor is, this is the first term, which is 3x, plus the second term, which is 9, multiplied by the first term, 3x, minus the second term, which is 9. So this is the way how to factorize two perfect square terms. If you check for the first factor, which is 3x plus 9, and the second one, which is 3x minus 9, we have something common, which is the common factor. So for both 3 and 9, we have the common factor, which is 3. So for the first factor, if we move the 3 outside, so the remaining of the first factor is x plus 9. This is multiplied by, again, we have another common factor, which is 3, and the remaining for the second factor is x minus 9. So we multiplied 3 by 3, so we have 9, multiplied by x minus 3, multiplied by x plus 3. So for this binomial, we have three factors. The first one is the 9, and the second one is x minus 3, and the third one is x plus 3. We can do the same formula, but with different technique. First, we can factor out the common factor before starting the factorization. So this is the original binomial. So the factor of x squared is 9 and the other factor is 81. So the greatest common factor for 9 and 81 is 9. So the remaining is simply x squared minus 9. So if you check for the value of x squared minus 9, simply we can conclude that it is a perfect two terms squared with minus sign between, so we can use the formula. So for the x squared minus 9, we can factorize it to x minus 3 times x plus 3. So the factorization of the original binomial, this is the GCF, or the greatest common factor, and this is the second term, and this is the second factor and the third factor. So these are the factors for the binomial. From now on, I will follow the second technique, which is based on the factorization out by using the greatest common factor, then complete. Let's solve this example together. Factor the binomial 16x squared minus 4y squared. So as you see here, we have something in common between the 16 and 4, which is the GCF. So the greatest common factor for 16 and 4 is simply 4. So the remaining of the binomial is 4x squared minus y squared. So we should keep the 4 here, and we should deal with this value, which is 4x squared minus y squared. So 4x squared minus y squared is simply, it can be converted into 2x all squared minus y squared. So we have here two terms, two squared terms, and we have a subtraction sign in between. So we can use the formula now. So this is the first factor minus the second factor multiplied by the first factor plus the second factor. Don't miss the 4, which is the GCF. So the original binomial will be, this is 4, and this is the factorization of the two squares terms. Let's do another example. Factor the binomial 16x to the 4 minus 16. So first of all, we have something in common between both 16. So the greatest common factor between 16 and 16 is simply 16. So if we put 16 out, the remaining of the binomial is x to the 4 minus 1. So don't miss this value, which is 16. Now we should factorize x to the 4 minus 1. But before starting the factorization, we need to make it as a squared terms. So x to the 4, simply it is x squared all squared. and 1 is simply 1 squared. So in this case, we have two perfect square terms. Now we can use the formula. So this is the first term plus the second term multiplied by the first term minus the second term. Now we should return the 16, which is the GCF. So the binomial is equal to 16 multiplied by x squared plus 1 multiplied by x squared minus 1. So we have three factors for this binomial. If you check for the three factors for this binomial, see that we have x squared minus 1, and simply x squared minus 1, it is same, it is squared terms, or we can make the factorization for this factor. So x squared minus 1, we have here two perfect square terms. The first term is x and the second is 1. So we can factorize the x squared minus 1. So it will be x plus 1 multiplied by x minus 1. So we replace the x squared minus 1 in the original procedure here. So what we have here, the binomial becomes 16 multiplied by x squared plus 1 and multiplied by the two new factors, which are x plus 1 multiplied by x minus 1. So in this case, we have four factors for this binomial. Let's factor the binomial, 2x minus 1 all squared minus 49. See that we have this term, it is squared, and we have here a minus sign, and regarding the second term, it's 49, and simply 49 is the multiplication of 7 by 7. So the second term, which is 49, it is simply 7 squared. So we have here a perfect square term for the second term. So now we can use the formula to make the factorization. So this is the first factor, which is 2x minus 1, and this is the second factor, which is 7. So this is the first factor, which is 2x minus 1 plus the second factor multiplied by the first factor minus the second factor. So we have now 2x minus 1 plus 7 multiplied by 2x minus 1 minus 7. So 2x minus 1 plus 7 is simply plus 6, and minus 1 and minus 7 is minus 8. So we have these two factors. If you see for the first factor, we have something in common between the 2 and 6. The greatest common factor between the 2 and 6 is simply 2. And regarding the second factor, we have a GCF between 2 and 8, which is 2. So if we move 2 outside the bracket, the remaining is x plus 3. And for the second term, if we move the 2 outside, the remaining is x minus 4. So now we can multiply the 2 by 2, and we have 4. So the basic binomial becomes 4 multiplied by x plus 3 multiplied by x minus 4. Let's see this example. By this example, we can conclude one of the applications of the formula for the squared two terms. What is needed here is we need to solve 8.5 squared minus 11.5 all squared. So we can simply conclude that we have two terms which are squared. The first one is 8.5 and the second one is 11.5, and we have a subtraction sign in between. So we can use the formula for the factorization between the difference of two squares. So we have two perfect square terms. So the first factor, this is the first term plus the second term multiplied by the first term minus the second term. So 8.5 plus 11.5, we have here 20, and regarding the second factor, which is 8.5 minus 11.5, we have minus 3. So we multiply 20 by minus 3. So we conclude that the value for the two difference of the squares is minus 60. That's all about the factorization of the difference of two squares. Thanks a lot for your watching. Goodbye.